Okay, so have you ever thought about like a light switch?
Uh-huh.
That can be on or off, right?
Yeah.
Pretty simple. Or maybe you're checking your phone to see if you have a new notification.
Right.
Like yes or no. Simple stuff, but these basic ideas like yes, no, on, off, true, false, they're really the core of how computers make decisions.
Yeah, it's amazing how like these simple choices
Yeah,
underlie everything in tech.
they do. They
Yeah.
really do. And that's actually what we're diving into today.
Okay.
We're talking about Boolean expressions. So these are basically ways of asking questions that have a true or false answer.
Gotcha.
And we've got some awesome resources for this. One is 3 video transcripts from Code Curious featuring Dr. Mitchell.
Okay, cool.
And they go deep into how these expressions are made and how they work.
Sounds good.
So the first video looks at relational operators. These are the tools that we use to compare different values.
Okay.
And then the second video builds on that by introducing logical operators. And these let us combine lots of conditions. And in the third video, we actually see how to put everything together and evaluate expressions that use both types of operators.
I like how Dr. Mitchell kind of builds up the content of the videos.
Yeah.
It's a really good way to learn.
Yeah, it's a good approach.
Yeah.
So what we really want to do in this deep dive is help you understand how to build and understand these really important pieces of computational logic.
Okay.
And we want to show you that this isn't some kind of like crazy complicated tech thing. It's something that can make a lot of the tech that you use every day way clearer,
Right.
no matter your background.
I like it.
So are you ready to get into it?
Yeah, let's start with those relational operators. I think those are a good place to begin.
Yeah, so relational operators are basically the tools that you use for comparing values. And Dr. Mitchell talks about a bunch of important ones in the first video. And the first one is equal to.
Okay.
And it's written with a double equal sign. So, you know, like number of students equal 30.
Gotcha. So you're asking if the number of students is exactly 30.
Yeah, exactly.
Okay.
And it's super important to remember that this is different from a single equal sign
Right.
that's usually used to assign a value to a variable.
Yeah, that's a really important distinction.
Yeah.
Because if you mix them up, it can really mess things up in your code.
It will.
Yeah.
You don't want to do that.
Like you're telling the computer that the number of students is 30
Right.
versus asking is the number of students 30.
Yeah, huge difference.
Big difference.
So then we have not equal to.
Okay.
And that can be written as bania, or depending on the language that you're using.
Okay.
Like Dr. Mitchell pointed out.
Right.
An example would be like count 10.
Okay, so that means the value of count, not 10.
Exactly.
Yeah.
And it's interesting how there are these little differences in the symbols,
Yeah.
but the main idea is the same.
Yeah, for sure. The logic is the same, but it's written differently,
Yeah.
depending on like the programming language or whatever you're using.
Right. And we have greater than and less than.
Yeah, the GLAP,
Yeah. Those are easy. So greater than is just the greater than symbol, like grade 70.
easy enough.
Yeah. And less than is just the less than symbol, like high score, current score.
So is the high score smaller than the current score?
Right.
Pretty simple.
Yeah, these are all pretty intuitive, I think.
Yeah, they are. I mean, these are like comparisons we make all the time,
We do.
every day.
Yeah, it's just a different way of writing them out so that computers can understand.
Right, exactly.
And then we have greater than or equal to and less than or equal to.
Okay.
So greater than or equal to is written with a greater than symbol and an equal sign.
Gotcha.
And again, this might look a little different depending on what you're using,
Right.
but a good example of this is like number of pets equals 0.
Okay.
So even if you don't have any pets, 0 is still greater than or equal to 0. So that would be true.
Right, because 0 equals 0.
Yeah. And then we have less than or equal to,
Okay.
which is the less than symbol and the equal sign.
Yeah.
And Dr. Mitchell gives this funny example of tacos. He's 3.
I like that example.
Yeah, relatable.
Yeah, everyone can relate to that.
I think so. And I think these are equal to operators are really important when you're trying to set like boundaries.
Yeah, for sure.
Yeah.
For example, like if a store has a sale where you get a discount if you buy 3 or more items,
Yeah,
you would use that greater than or equal to.
you would. You would. And to make these ideas a little bit more real, Dr. Mitchell actually gives us some examples from her own life.
Oh, cool.
So she asks if her hair color is black,
Okay.
and that's true.
Yeah.
And then she asks if she was born in November, and that's true.
Okay.
But then she asks if she has a cat,
Okay.
and that's false because she's a dog person.
I like that example.
Yep.
Because it's so simple, but it shows you how you can use true and false values to represent like real stuff.
Yeah, exactly.
It's not just like an abstract concept. It actually means something.
It does. And then she talks about like that classic example of, are you old enough to drive?
Oh, yeah.
Which translates to the Boolean expression age 16.
I remember when I turned 16.
Yeah.
That was a big day.
Yeah, that's a good example of a greater than or equal to.
Yeah, for sure. And it's something that like we all have to deal with at some point.
Yeah, we do.
Those rules and stuff.
Right.
That's all based on Boolean expressions.
Exactly. So then there's this other really cool one called the modulo operator.
Okay.
And it's often written as mod or as a percent sign.
Okay.
And what this operator does is it gives you the remainder after you divide.
Okay.
Which is really useful for things like checking if a number is even.
Okay.
So the example is number mod 2 equals 0.
So if a number is divisible by 2,
yeah,
then it's even.
Right, because there's no remainder.
Right. Okay, I got it.
Like if you were sharing cookies between two people
Huh.
and there were no cookies left over,
Right.
then, you started with an even number.
Yeah, that makes sense.
And the modulo operator is really cool because it lets you do more than just compare the size of numbers.
Yeah, it lets you look at different properties of numbers.
Yeah.
Like you could use it to see if something should happen every 3 times and if it occurs or something like that.
Yeah, you could. You totally could.
That's cool.
So to help us practice, Dr. Mitchell gives us some examples in the video.
Okay.
The first one is checking if the average of 3 grades is at least 70.
Oh, okay.
And the expression for that is grade 1 plus grade 2 plus grade 3, 3 equal to 70.
Okay, so you add up all the grades, divide by 3,
Yeah,
and then see if that's greater than or equal to 70.
exactly.
Okay.
And it's important to remember that the parentheses here are really important.
Yeah, why is that?
Well, because they make sure that you do the addition and the division before you compare to 70.
Oh, okay, so it's like the order of operations.
It is.
That
It is like
does.
in math.
Makes sense.
And then the next example is determining if a number is odd.
Okay.
And the expression for that is num mod 2 equals 1.
Okay, so this time we're using the modulo operator.
We are, because if a number's odd when you divide it by 2, you'll always have a remainder of 1.
Oh,
So that's how you check.
So again, we're using the modulo operator to figure something out about a number.
Yeah,
It's pretty versatile.
it is. It is. And then finally, there's a really simple one, checking if the temperature outside is less than 90 degrees,
Okay.
which is just temp 90.
Easy peasy.
Yeah. So as you can see, relational operators are all about asking these basic comparison questions.
Yeah, and getting a true-false answer.
Exactly.
Okay, cool. So now we know how to ask those basic questions, but how do we connect them together?
Well, that's where logical operators come in.
Okay.
And these are the tools that let us take multiple Boolean expressions and combine them into one single true or false outcome.
Okay, so we're getting more complex.
We are. And Dr. Mitchell covers 3 main ones in the second video, not, and, and, or.
Okay, I've heard of those before, but I'm not really sure how they work.
So these operators let us make more interesting and powerful conditions
Gotcha.
by linking together those simpler true-false statements that we talked about before.
Okay, that makes sense.
So let's start with the not operator.
Okay.
It's usually written as not, but sometimes you'll see it written as an exclamation point.
Okay.
And what it does is it flips the truth value of an expression.
Oh, okay.
So if something is true, then not true becomes false.
Right.
And if something is false, then not false becomes true.
Okay, so it's like saying the opposite.
Yeah, exactly. Like saying it is not the case that...
Gotcha.
And Dr. Mitchell uses this example of is raining.
Okay.
So if the variable is raining is false,
Uh-huh.
then not is raining would be true.
Good.
But it's important to remember that the not operator doesn't change the value of that original variable.
Right.
It just gives you the reverse.
It just flips it for that one time.
Yeah, exactly. It's like a temporary switch.
Gotcha.
And then we have the and operator, which
Right.
is often written as and, or, and e.
Uh-huh.
And for an entire expression using and to be true, all the conditions have to be true.
Oh.
So if even one part is false,
Uh-huh.
the whole thing is false.
The whole thing is false.
Yeah, it's like needing your keys in your wallet to leave the house.
Yeah.
If you're missing either one, you're not going anywhere.
You're stuck.
You're stuck. And Dr. Mitchell gives this really good example using grades.
Okay.
So if your grade is 85,
Uh-huh.
then the expression grade 70 and grade equals 100 is true,
Okay.
because 85 is greater than 70 and it's less than or equal to 100.
Right.
But if the grade was 43,
Uh-huh.
then the expression 4370 and 43 equals 100 would be false.
Right.
Because even though 43 is less than or equal to 100,
Yeah.
it's not greater than 70.
It's not greater than 70.
So both sides of the A and D have to be true
Right.
for the whole thing to to be true.
Gotcha.
And the A&D operator is really helpful when you have multiple conditions that all need to be met.
Yeah, for something to happen.
Yeah, for something to happen.
Okay.
Then we have the OR operator,
Okay.
which is often written as or, and this one is a little more flexible.
Okay, how so?
So an expression using or is true if at least one of the conditions is true, and it's only false if all the conditions are false.
Okay.
So think of it like this. You're deciding what to do on your day off. You could go hiking or you could visit a museum.
Right.
If you do either one, or even both,
Yeah.
you've accomplished your goal.
You did it.
You did it. But if you do neither,
Then you haven't.
then you haven't.
Okay, I like that.
So Dr. Mitchell illustrates this with a score and lives example.
Okay.
So let's say your score is 175
Huh.
and you have 2 lives left.
Okay.
So the expression would be 175, 150, or lives equals 0. And that expression is true
Okay.
because the first part, 175, is greater than 150 is true,
Right.
even though the second part, lives equals 0, is false.
Right, so only one of them has to be true.
Exactly. Only one has to be true. But if your score was 100
Okay.
and you had 1 life left,
Yeah.
then the expression 100, 100, 150, or lives would be false
Okay.
because neither of those is true.
Right, because neither part of it is true.
Exactly. So the OR operator is super helpful when you have different situations
Yeah.
that should all lead to the same result.
Right, okay, so it's kind of like a multiple choice.
Yeah, you could think of it that way.
If any of these things are true, then do this.
Exactly.
All right.
So Dr. Mitchell gives us some more practical examples to help us understand this.
Okay, good.
So the first one is you can go out if you did your homework and your score is at least 80.
Okay, so 2 conditions.
Yeah. And they both have to be true.
Yeah, like my parents used to say that to me all the time.
I bet. And the Boolean expression for that is did homework and score, it's 80.
Okay, makes sense.
And then the next example is you can leave your umbrella at home if it's not cloudy and the temperature is greater than 75.
Okay, so again, 2 conditions.
Yeah, and the expression for that is cloudy and temperature 75.
So it has to be not cloudy and the temperature has to be over 75.
Yeah, exactly. You've got it.
Okay, cool.
And this one shows how we can use the not operator with the and operator
Right.
to really make things specific.
Gotcha.
And then there's a really complicated one. You win the game with at least 20 points and 3 lives left, or 100 points and more than 0 lives.
Wow, that's a mouthful.
I know, right? And the Boolean expression for that is score 20 and lives equals 3,
Yeah.
or score equals 100 and lives 0.
Okay, so there are 2 ways to win.
Yeah.
You can either have 20 points and 3 lives left,
Yeah.
or you can have 100 points and at least 1 life left.
Exactly.
Okay, and the parentheses are important here, right?
They are. They tell the system to evaluate those conditions first.
Okay, so it knows what to do first.
Right.
Gotcha.
So this example shows us how we can use A&D and OR together, along with parentheses, to really represent these complex decisions.
Yeah, where there are lots of different ways to be successful.
Yeah, it's pretty neat.
It is. It's like a choose your own adventure.
You could think of it that way.
All right.
So we know how to ask these basic true-false questions using relational operators.
Right.
And we know how to connect them using logical operators.
Uh.
But what happens when we put all of that together in one expression?
Yeah, that's a good question. Like, how do we actually evaluate those?
Well, that's what the third video from Dr. Mitchell is all about.
Okay.
She shows us exactly how these things are evaluated in real life.
Cool.
So let's take the first example.
Okay.
We have a variable num that is set to 7.
Great.
And then we have is even, which is assign the result of num mod 2 equals 0.
Okay.
And since 7 divided by 2 has a remainder of 1,
Yeah.
is even is false.
Right. 7 is not even.
Exactly. And then we have range, which is assign the result of num 5 and num equals 10. And because 7 is greater than 5 and 7 is less than or equal to 10,
Yeah.
range becomes true.
Okay.
And then the system evaluates even or range,
Correct.
which is false or true.
Right.
And remember with OR, if at least one side is true, the whole expression is true.
Yeah.
So the final answer is true.
So it's true.
It is. And this example shows us how the system evaluates things. It does the relational comparisons first, and then it combines those results.
Using the logical operator?
Right.
Okay.
And then another example uses a name and an age.
Okay.
So name is Mitchell, and age is 34.
Okay.
And the expression is not name Mitchell or age 40.
Oh, okay. Another complex one.
Yeah, but let's break it down.
Okay.
So first we look inside the parentheses. Name Mitchell is true.
Right.
But then we have the not operator right outside.
Good.
So not true becomes false.
Okay.
And then on the other side of the OR, we have age 40. And since 34 is less than 40, that's true.
Right.
So now the whole expression is false or are true,
Okay.
which again is true.
It's true.
Because one side is true.
Okay.
And this shows how important parentheses are.
Yeah, why is that?
Because they tell the not operator to only work on the stuff inside those parentheses.
Oh, okay, so it's like telling the not operator what to focus on.
Yeah, exactly.
Gotcha.
So then Dr. Mitchell gives us this AP-style question, which is a really great way to test if we understand how this stuff works.
Yeah, those AP questions are tough.
Yeah, but they're good practice.
Yeah.
So the scenario is about driving and voting ages.
Okay.
In this country, you have to be at least 16 to drive
Okay.
and at least 18 to vote.
Uh-huh.
And we have to figure out a Boolean expression that is true if someone can drive but can't vote.
Okay, so they're old enough to drive, but not old enough to vote.
Right. So here are the options.
Okay.
Age 16 and age 18.
Okay.
Age 16 and not.
Okay.
Age 18 and not. Age 16.
Okay, so 3 options.
Yeah. And we have to figure out which one is correct.
Okay, so let's go through them.
Okay, so the first option,
Fine.
age 16 and age 18.
I don't think that one's right.
Why not?
Well, because it includes the case where the person is 18.
Oh, yeah, you're right.
And at 18, you can vote.
Yeah,
But we want the expression to be true when you can't vote.
exactly. Good catch.
Okay, so what about the second one?
Okay, so the second option is age 16 and not age 18.
Okay.
So the first part checks if they're old enough to drive, and the second part checks if they're not old enough to vote.
Because it's not age 18.
Exactly.
Okay, so that one looks good.
It does. It does. What about the third one?
Okay, so the third one is age 18 and not age 16.
Mm-hmm.
So the first part means their age is less than the voting age,
Right.
so they can't vote.
Yeah.
And then the second part means they are old enough to drive.
Yeah, because it's not age 16.
Right.
So that one's also correct.
Oh, so they're both right.
They are. They're both correct ways to write it out.
Wow, so there can be more than one right answer.
There can. And it's a good example of how there can be multiple ways to express the same logical condition.
Yeah, and that AP question was really good because it made us use all of the things we learned,
Yeah.
like the relational operators and the logical operators and the parentheses.
It did. It did. It was a good challenge.
Yeah.
So just to sum everything up, relational operators are tools for comparing values and getting a true or false result.
Right.
And logical operators let us combine and change those true or false outcomes to make more complex conditions.
And together, those make up Boolean expressions.
Exactly. Which are at the heart of how computers make decisions.
Yeah, it's pretty amazing when you think about it. Like all of these complex things that computers can do, they all boil down to these simple true or false evaluations.
They really do. And that's why understanding Boolean expressions is so important.
Yeah.
It's not just some random computer science topic. It helps you understand how the technology you use every day actually works.
It's like seeing behind the curtain.
It is. It is. And hopefully this deep dive has helped you understand these concepts and maybe even given you some of those aha moments.
Yeah, for sure.
But if we take this even further, like think about how even the most complicated decisions that software makes, like recommending music or products or driving a car,
Self-driving cars.
yeah, all come down to a bunch of true or false evaluations, which I think is pretty incredible.
It is. It is. It really makes you think.
It does. So here's a question for you. What other areas of technology could you understand better if you broke them down into these basic logical steps?
That's a good question.
Yeah, I think you might be surprised by how much the technology we use relies on these simple true-false decisions.
Yeah, I think you're right. It's like the secret language of computers.
It is. It is. So we encourage you to keep exploring and see if you can find Boolean logic in other places.
Yeah, you never know where it might pop up.
You don't. You don't.
Awesome.
Thanks for joining us.
Yeah, this was fun.
It was. It was.